All right, here we go. It says write sine of arctan root 3 plus arc sine of x as an algebraic expression of x that does not involve trig functions. All right, well, so first of all, I want to know, can we find arctangent of square root? I think we can find that. And can we find something to replace arc sine of x with? Can we do that? Can we start from the inside and work our way to the outside? That's what I want to do. I know that arctangent root 3 is pi over 3. I know that. I know it because I know pi over 3 relates to the point 1/2 root 3 over 2, and I know if I take sine divided by cosine, I get square root of 3, so I know this is pi, this is really sine of pi. I'm already starting to make that look a little bit better. Over here, arc sine of x, that's a little bit more tricky. If I draw a triangle to represent this, a right triangle, sine is opposite over hypotenuse, that would be x over 1, thinking on my unit circle. That would make the third side square root of 1 minus x squared, just in case I need that. And so what is that angle? I'm just going to let it be theta. We don't really know what that angle is yet, and we probably won't need to really figure it out. But that's the angle that's represented by arc sine of x. I'm letting that refer back to this triangle, and I can always get that stuff if I need it. I'm going to need it. So now I can use my sum identity of sine, and sine of pi over 3 plus theta is, if I refer back to that identity, yes it is, sine of pi over 3 cosine of theta plus cosine of pi over 3 sine of theta. That is my sum identity. And now I can start evaluating these things. Sine of pi over 3 is root 3 over 3. Sorry, root 3 over 2. Cosine of theta, cosine would be adjacent over hypotenuse. That's just going to be square root of 1 minus x squared. Okay, getting somewhere. Cosine of pi over 3 is 1/2, and sine of theta, we know what sine of theta is. It's been x. It's been x this whole time. Simplify this down a little bit more. Here, this is just a fraction, so I can multiply that. Has a denominator of 2. When I multiply radicals and they have the same index, well, I can just multiply the stuff on the inside. This is really root 3 minus 3x squared. Over here, I have x over 2. If I add this stuff together, I can pretty much just make it as one fraction. I could honestly leave it like this. This is kind of fine right here, but the best answer, I think the best answer would be x plus root 3 minus 3x squared over 2. I think that's the best answer, putting that x in front so it doesn't get confused about being under the radical or anything like that. Best answer right there. We've made it a single algebraic expression with x that does not involve trig functions. Look at us. Killing it. We want to do some verifying here, verifying the cofunction identities here. Well, all I really need to do is plug that into my difference identity, and then I'm pretty sure it's going to simplify down to be cosine of x. That's what's going to happen. So this is sine of pi over 2 cosine of x minus cosine of pi over 2 sine of x. What is sine of pi over 2? It's 1. This is 1 cosine of x. What is cosine of pi over 2? That's 0 minus 0 times sine of x. Well, 0 times anything goes away, just like that, and all we're left with is cosine of x. We have indeed verified it. Got All right, here says sum and difference identities can be used to rewrite trig expressions in which one of the angles is a multiple of 90 degrees or pi over 2 radians. The resulting identities are called reduction identities because it reduces the complexity of the expression. And we can prove those. We can show that these actually do make sense. Here, we want to show that this is the same thing as negative cosine of theta by just using our sum identity. We know this is sine of theta cosine of 3 pi over 2 plus cosine of theta sine of 3 pi over 2. Sine of theta, I'm going to leave that alone, but cosine of 3 pi over 2, we know what that is. We go all the way around, that cosine would be 0. Cosine of theta. Sine of 3 pi over 2, that's a negative 1. This, of course, is out, but this is a negative cosine of theta. And so we've shown that this is indeed true. Look at that. We just verified that reduction identity. On B right here, we can verify this reduction identity also. Of course, we want to use our difference identity with tangent. That would be tangent of x minus tangent of 180 over 1 plus tangent of x tangent of 180. Okay. All right, we start simplifying. This, of course, is just tangent of x. Tangent of 180 degrees, it's 0. On the bottom, we have 1 plus tangent of x times tangent of 180, which we know at 180, tangent of 180 is 0. So we're starting to simplify things down here. Tangent of x minus 0 is just tangent of x. On the bottom, we have 1 plus 0. So tangent divided by 1 is still just tangent of x. We've done it one more time. We have verified using our sum or difference identities.